Okay, so in this video, we've just looked at fitting a binomial distribution, and we've said that it has to be discrete, and we said that the probability has to be fixed. Each trial has to be independent. There have to be two outcomes, and there has to be a fixed number of trials. And of course, I got to the end and I was really happy, and then I suddenly realized I should have mentioned that sometimes we kind of know one of those may not be true, but we just have to roll with it to be able to work out a probability, because otherwise we might not be able to get an answer. And then if we have any doubt about the independence or the probability is fixed, then we talk about that a bit later. Okay, but so this video was primarily about being able to work out the probability of one of these. So if I look at the question, we kind of done the first part, but we have to use an appropriate model, calculate the probability that fewer than 3 of these employees will be unavailable when called. So that's where we actually have to work out a probability. So I've got my trusty calculator, and that's going to help me. Now, there might be some of you with a slightly newer version of this calculator than I've got. That's cool, because most of this is exactly the same. The menu system is roughly the same, even on the newer calculator. The only time that we might have a bit of a problem is if we start talking about inverse binomial. There's going to be a separate video about that. I would prefer you did that and solve that without using the inverse binomial function that's on your calculator, because to be honest, I don't know what that's doing. So until I know and I've had a chance to play with that, I'm not prepared to use that as my technique. So same with the Poisson. I've got a separate video about working out the inverse Poisson, and inverse normal straightforward because we just use the calculator. So here we go. So I'm on the main menu. I've clicked menu and it's taken me to the main menu. And of course I want to do stats. So I'm going to press 2. And at the bottom here, it gives me the options. And so I'm going to use distribution, and that's F5. And then I'm going to go to binomials on F5. And that's when I get to my first choice. So I've got B, P, D, and B, C, D. B, P, D is for when I want to work out an exact value. Okay? So BPD is a binomial point distribution. So I want to work out an exact, having terrible trouble writing, so let's try again. Still getting used to using the tablet on the Mac. So it's an exact value. So what I mean by that is, if in the question it said, what's the probability that exactly 3 people were available, I would use a BPD. BCD is a binomial cumulative distribution. So that is a less than or equal to. So that would be the probability that X is less than or equal to 3. And it would add up the probability of 3, the probability of 2, the probability of 1, and the probability of 0. And that's great. The problem comes that imagine it was less than, but not including 3, or more than 3. My problem with the BCD function is it has to be a less than or equal to. So if I want to do less than 3, then I wouldn't do less than or equal 3, I'd do less than or equal to 2, because I've got to make it 1 smaller. And if I want to do greater than 3, greater than 3 does not include 3, so I'd work out the probability of less than or equal to 3, and then subtract that answer from 1, because A binomial is either success or failure. And when I get to the end, it's still going to be success or failure. So you've just got to kind of somehow turn your mind around to make sure that you're using the right function for these. Okay. So if it's an exact value, you always use BPD. If it's a less than or equal to, less than, greater than or equal to, or greater than, you're going to use BCD. But when you get to that, you're going to have to think very carefully about how you do that. And there's a good slide about this one in the Google Slides that I put up that review the whole distribution. So go and have a look there. In this case, it says calculate the probability that fewer than 3 of these employees will be unavailable when called. So fewer than 3. Well, the first question I always ask myself is, does that include 3? And it does not. Fewer than 3 does not include 3. So actually, I'm working out the probability that X is less than 3, which is going to be the same as the probability that X is less than or equal to 2. So at this point, I need my calculator and I need to think about all my situations. So I'm going to write this down in a more mathematical sense, that I've got all my information carefully sorted so that I can quickly work this out in a second. So my number of trials is n. So I know n is 8. I know p, which is my number of, is my probability, is 0.14. I know my value that I'm working out, in this case it's going to be X, is going to be 2. Okay, so that's because my value here was 2. So here's my calculator. I know I'm going to a BCD. First thing I've got is it's telling me I've got the choice of having my data as a list or my data as a variable. I need to remember to turn it to variable. The first time you do that in the exam, you'll have to do that. After that, it will just remember depending on which function you're in. Okay, so my X is 2. I want it to be less than or equal to 2. My number of trials is 8, and my probability is 0.14. And I click answer, and the probability that fewer than 3 of these people will be unavailable is 0.9109. So that's my answer. So there you go. I've managed to answer my probability question. Couple of quick things about the calculator. If I need to now use that answer, I can go and I can use the answer button, and that probability has been stitched into the answer button. So if I then have to use that answer because I need to subtract it from 1 or whatever else, I can do that really simply. Okay? One other thing about the binomial, just so that we've got it somewhere so that you can refer back to it, is 2 little things. The mean of a binomial is mu, and that is the number of trials times the probability of success. And the standard deviation of the binomial, which is sigma, is the number of trials times the probability of success times the probability of failure, which is the probability 1 minus the probability of success, and then you have to square root that. Okay, that of course is given to you on the formula sheet. On the top of your formula sheet you have a table for the binomial distribution, and it gives you the formula if you're using the formula, and it gives you the mean and standard deviation equations there. So that's all available for you. Okay, so that's using the binomial. And now we've got to do an inverse binomial question, and then we're done with the binomial. We can move on to the Poisson. Okay, have a great afternoon.